concept of immutability. The next feature is that an object-oriented database allows me to have complex objects. Okay, so what do we mean by complex objects? A complex object basically means that there is no restriction in the structure of objects. The object can be created in any manner as a database user deems fit. Okay, so in an object-oriented database, an object is represented by let's suppose this is my object, then this object is represented by a value of 3 elements, or rather by a triple. Okay, we call these 3 elements as a triple, and these 3 elements are, let me do it like this, I, C, V, where my I is the object identifier, C is the type constructor. I'll just let you know what a type constructor is in a moment, and my V is the value of this object. Okay, now let's see what a type constructor is. A type constructor is basically something that allows me to determine how this object is constructed. So my type constructor determines how the object is constructed, or in other words, it tells me the basic structure of an object. The basic structure of an object. Okay, so what is the meaning of this basic structure? We will see what are the different types of type constructors, and we'll understand what is this basic structure means. Okay, so kinds of type constructors. Okay, so we'll just quickly look at each one of them. The first is an atom. An atom type constructor says that the object is storing an atomic value. Okay, an atomic value. Okay, so it's something like you can store a string in this. Okay, so this is an atomic value. That's an atom. Now the next kind is set. Set tells me that object stores set of values of same type. Set of values of same type with duplication allowed. Okay, with duplication allowed. So what can be a set? A set can be a collection of atomic values, or it can be a collection of different complex objects. Okay, the same type we are saying, this type can be an atom or any other kind of type constructor. We will just understand what are all types of type constructor over here. So let me just give you an example over here. Let's suppose I can have values like 1, 2, 3, 4, 5, 6, 6, 7, 8. Then I can again have 1, 2, 3, and I can have 7, 8, 9. This is allowed because this is a set. Next type of type constructor is a bag. bag is a set with no duplicate items. Okay, no duplicate items. So an example of this would be the same as this one, but we would have only 1, 1, 2, 3. Okay, so this is what I am looking at when I'm talking about a bag. Okay, next type constructor we're going to see is a list. List is an ordered collection of values. Ordered collection of values or objects. Ordered collection of, we would rather use the term items of same type. Okay, so in a list we can refer to the first object, second object, third object, and so on. So what is going to be my list? My list is going to be something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 7, 3, and we would have this as the first element, this as the second element, this as the third element, and this as the fourth element. Okay, so I can refer directly to the third element if I want to. Okay, and finally we have an array kind of type constructor. Array is similar to a list but with a fixed size. Okay, array is the same array that we use in programming languages. A list can be expanded indefinitely. I can keep on adding elements here. Okay, I can add more elements at the end as and when I require, but array has a fixed size. And the final and most important kind of type constructor is the tuple. Tuple is a collection of elements of above types. Okay, so a tuple can have an array, list, bag, set, or atom in any particular order. Okay, so what is my tuple? A tuple can be something like, let's suppose I create a tuple like this. I have a name which is an atomic type constructor. Okay, then I have, let's suppose I have a set of locations. Okay, set of locations, and I have, let's suppose, an array of employees. Okay, and stuff like this. So this is my tuple. Okay, so my name is an atomic type constructor over here. My set of location is a set. My array of employee is an array. Okay, and this whole collection is called as a tuple over here, right? A tuple is represented in the form of this arrangement. Okay, we list down the attribute. Okay, and then we list down the object ID of that attribute, as in if my attribute is name, okay, and my name is containing a value. Let's suppose I have an object which stores the value rebel. Okay, this is an object. So let's suppose I call this O1. Then we are going to have something like, and let's suppose this OID of O1 is I1, then I would have something like name colon I1, which says that name is an object whose object ID is I1. Okay, so we store it as A1, I1, A2, I2 and so on. Okay, AN, IN. So how would I store my above tuple? I would store it as like this. I would have my name, I would have a set of locations. Let's suppose this set is having an object identifier I2. Okay, and finally I have an array of employees, and this array of employees is stored in an object which is having an OID I3. Okay, just understand over here that all these elements in a tuple are themselves objects. Okay, so these are objects. Okay, let's see how other tuple or type constructors are represented. A set or a bag is represented by the object identifiers of their elements. So we would have I1, I2, I3 to IN. Just realize that a tuple has elements with different types, therefore we also represent the name of the element, while a set or bag has only elements of the same type, hence we represent only their OIDs. Similarly, for an array or a list, the representation is square brackets along with the object IDs. Okay, so that's how we do it for array or a list. Another thing in complex objects that an object-oriented database support is the complex object itself can be of two types. Okay, it could be a structured complex object, or it could be an unstructured complex object. Okay, so a structured complex object has a particular structure, which means it is of the type tuple. Okay, and unstructured complex object has no specific type. Okay, so